So hi everybody. So I'm Jonathan Grenier. I'm here for building MSP infrastructure with my, oops, I'm gonna have to stop moving. Building MSP infrastructure with Mikrotik. So about me. So I'm a network consultant at Solution ISG here based in Montreal. I'm a Mikrotik certified trainer and MTCNE, MTCRE, and I accumulate about 20 years of experience in IT, networking and also system. I have a background, Unix background, which led me to Mikrotik. From my Linux experience in networking, I figured out that Mikrotik was a lot easier than doing everything command line and giving me the same result faster. So about Solution ISG. The company was founded in 2007. We are a managed service provider, and we're based here in Montreal, but we support clients all over the world, mainly in Canada and the US as well. So, as a managed service provider, we had multiple challenges in order to offer better support to our customer. This led us through a few small projects, and after a couple years of development, it brought us to a complete solution for our needs. So basically, we started with nothing, and through time, we built the infrastructure to fulfill the need that we had as an MSP. So the goal of this presentation is to give you a functional and technical overview of our solution. So you can see all the potential and advantage of Mikrotik Router OS and Router Board have to offer. So basically what I mean by that is that we cannot cover in 30 minutes all these technical details, but we'll go through the solution, well, basically the requirement that we had at the beginning and what we came with as a solution and how we implemented it. And a few examples of how we configure it and basically give you the guidelines if you want to do the same thing in your own infrastructure, how to do it. So the basic requirements, we had three major ones. The first one was accessibility, which is, well, those requirements are in order, and accessibility was the main one. So we want to provide a simple and standard method to access client infrastructure. We also wanted to give our team efficient ways to work and the ability to multitask. And we'll see why later, what were the challenges in details. Second point, and also another very important one that needs to be, you can't forget it, is security. So by building networks and connecting clients, you need to emphasize on security. And it was to protect our network and our clients' networks, because by building this big network, we're connecting clients with clients and through our infrastructure, so we create potential risk if we don't manage those risks properly. And we also wanted to provide the ability to audit what's happening, because we don't want some technician to access client network and then just have no idea who was connected, because it's really important to have an idea who's doing what. So that was one of the requirements as for security. And the last was the cost. So the market competition led us to find the most cost-efficient way to deliver a solution. It is very important to provide the customer with the better return on investment. So that was one of the main criteria for the solution as well. So if we go through the requirement, the first one was accessibility. So one of those requirements was the possibility to access multiple clients at the same time. And the second point is related to the first one, is in some case, your client might have the same subnet in their own network. So what led us to that problem was, at the beginning, we were using VPN to each client. And so if you had the same subnet on two clients, and even so, I mean, you were not able to do work at two sites at the same time. It doesn't mean it had to be the subnet, but a rule where the routing would be sent through the wrong VPN, or, there's a lot of possibilities. But by doing, that was a requirement to remove that from the picture. So we wanted something simple, and VPN was then removed as a solution. Also, we wanted access for central monitoring, because as an MSP, you need to be able to see what's happening on your client side all the time. So that was another requirement. As for accessibility, our central console needed to be able to access each client all 24/7, so basically all the time. And mainly, we wanted simple deployment. So simple deployment, we wanted to be able to have a level 1 technician go on site and just install a simple device. If he had to do some configuration, keep it simple, have a simple recipe that anybody basically could put in place. We didn't want something complex, so we wanted something easy, which goes with the cost point we had earlier. So if it's complex, you're going to spend more time, then it costs you more. So we wanted the solution to be simple, and also we have the access for the client needed to be simple. The technician, we didn't want something that we would have problems and people would take time to troubleshoot. We wanted to keep it as simple as possible. So, and then the second point, we have the security. So we wanted a web-based authentication with what we call WebAuth. So I don't know if any of you is familiar with WebAuth on Checkpoint Firewall. So we wanted something similar to that feature. So a user could authenticate on a web-based interface and open firewall rules. So simple, efficient. If your network is up, that's all you got to do. So that's what we wanted. We wanted centralized user control, because if we go back to the VPN per customer, so it means that if something goes wrong with someone and he leaves the company, then we had to change password everywhere. So we wanted something to centralize the passwords. And also we wanted encrypted communication between sites. I mean, this is pretty much basic, but it's a requirement. We wanted to be able to put rule sets per user or group. And we wanted to be able to restrict client access. So basically, client was not able to get into our network and other customer by the same way. So those were the security requirements. And then financial requirement, well, it comes back to low-cost client device when a dedicated equipment is required. So what we mean by that is, for instance, if a client has a different router than Mikrotik and we have to push hardware to be able to have a door in their network, we didn't want to spend like $500 per device or per site. So in some case, maybe a 750 would do the job, or any other cheap hardware. So that's one of the criteria to decide on the solution. And also, since we were a Mikrotik shop, we wanted to maximize the return on investment, because most of our network was already Mikrotik. So the solution, obviously, using Mikrotik products for the low cost of ownership. So that was, I mean, we knew that pretty much from the beginning, but I mean, it just made sense, because there's not a lot of solutions that are so flexible and cheap. Then we decided to tweak the hotspot to become a web authentication using the radius that solved the issue of the central authentication. So we connected through our Active Directory / LDAP, depending in the case, in our infrastructure. Then Mikrotik provided us the site-to-site VPN. We decided to use the built-in firewall to control access from client and internal users, and also using the Netmap to be able to overcome the problem of subnets. So making a network architecture on our side, define subnets for client, and then net mapping to the proper subnet on the client side. And finally, using OSPF to dynamically configure routing on our network, what we call ISGNet. So basically, this is a simple diagram. It's not exactly what we have in production, but I just tried to keep it as simple as possible to explain how it works. So here, on top, we have two clients, pretty much simple setup, but a typical setup. And on the other side, we have the ISG network. So on here, you have the support, like where the people are working, the office. And here we have data center side and the routers that are involved in the whole process. Obviously, this is for two customers, but in production, it's way larger. There's a lot more computers connected to that network. But for today's matter, that's what we're going to work with. So WebHot. So we're using RouterOS hotspot functionality to a private network rather than the internet. So basically, there's no huge change there, but the idea is rather than pointing to the internet, we're pointing to a private network. So you have to authenticate like if you would go on the internet, pointing on a website, or just an IP on the client side, and then you get the WebHot page, and then you enter your credentials, and you're allowed to access what you have access to on the network. So basically rule sets. Or if you keep it simple, it could be just the whole client network side. It provides a simple access control from internal network to customers. It provides the ability to log user activities. So you could log the logins and you know which IP is connected to which client. And I mean, with all the features that you have in the Mikrotik system, you could go even deeper, but it gives you a good idea of who's doing what on your network. And also it limits session time. So basically, if a user activates a session after a certain time, he's being disconnected. So his laptop is not always connected to the client network. And also it protects from concurrency. We'll see later how we fit that. But it allows only one session per user, per password that you have allowed. So here we have a simple configuration on RouterOS, nothing very complicated. Here we have the hotspot configuration to our interface that in the diagram was entered 3. And basically the only other thing we need to set is the name of the hotspot and the profile that we'll configure later here. And then we have the user profile. Mainly the user profile is used for the session timeout. In our case, we put 12 hours. Because 8 hours, we had 8 hours at the beginning, but sometimes, as you know, in IT, we work a little more than the regular 8 hours, and it was a problem if your session got disconnected after like 6 if you were there early in the morning. And also the shared users. So basically, it limits one username can connect from one IP, and that's it. And finally, we have the hotspot profile. What we define there is the directory where we put our HTML file to customize the hotspot. Then the login by, the name of the profile, and the authentication. As we're using Radius, we have to define it in the hotspot profile. So that's pretty much what you got to configure to get a functional solution. I mean, it's pretty simple. In that case, you need your Radius, obviously, to be configured. But you'll get like a wall protecting you until you authenticate to your client as you would do in a hotspot. So here we have an example of someone logging in the hotspot, or as we call it, WebHot. So you have here the person would type the IP on the client side and get his login, and when it's done, if there's a web page on the other side, let's say there's a web interface on the client side, you just access it and can do your stuff. Or if you want to use Winbox, then you just go in Winbox and do what you have to do. So here we have how to configure the Radius side. So the Radius side is to centralize the user management, as I mentioned earlier. And it allows you to revoke access through your AD in a matter of clicks. So you could almost have anyone who has access to manage rights on your network, remove a group or just disable access, and then the person is been revoked his access to your network. So it's in a matter of click, and it doesn't take a technical person to do it. So it could be given to HR or any other department in the business, depending on your model. So the configuration is pretty simple. So basically we have the server, and which by the way is not a true IP. I left IPs, but don't even try it. You're not gonna get anywhere. I didn't leave those addresses in there. And the password is not a true one either. But basically that's what you have to set. The IP, the domain, secret, and the service that you wanna allow, which is the hotspot in our case. Again, what we call WebHot. So Radius has another nice feature with Mikrotik. Using the Mikrotik Mark ID as a Radius attribute, you can define an attribute that will allow you to put rules per group, as I was mentioning earlier. Because by default, the hotspot, you open it and you have access to everything that's on the other side. Well, this will allow you to push a group, then put rules, and for instance, you could say this tech level 1 only have access to, we'll say 10.20.00/16, which is desktop network. Or if you want, you could put like 10 rules. It's only a matter of using because it's going to create a router mark in the mangle, the dynamic rule as we see here. That's what you get basically when you log in. So it puts the client IP, and it marks every packet with the mark netadmin in my case. If we go, well, yeah, the netadmin is my the mark ID I specified in my Radius server. Just one important note, I don't know, I didn't put that rule in there, but it's going to create you a dynamic rule, which is great, but by default, the chain is hotspot, and there's nothing pointing to hotspot. So those rules will be useless unless you go and put in your mangle, in the chain forward, send it to hotspot for all packets. Otherwise, it's not going to do anything good for you. The counter will stay at 0. So then we get into the VPN. So Router OS, as you know, has many options for VPN. The best suited for our case was IPsec and then SSTP, because IPsec covers a lot, but not all cases. If you have dynamic IPs, if you have firewall, if you have NATing, it might be an issue, where SSTP, since it's using SSL, goes through a lot compared to IPsec. So in our case, in some clients, we're using SSTP, but if you were not able to use IPsec. So it provides a permanent connectivity to client equipment, which is required mostly for backup and monitoring. So we're able to send all our traffic through this infrastructure, keeping it encapsulated through the same VPN. We only have one tunnel per client going back to our data center and then to our network. So as I said, the SSTP can be initiated by the client. So if you don't have static IP, it will come to your server without any knowledge of their IP and behind that. Then for security, we mentioned firewalls on the client router. Obviously, it protects us from a client accessing our network using source NAT. So basically, since when we're going on their network, they have no idea of our address scheme. So basically, we have to source NAT our IP when we enter their network, which has two great effects. I mean, it allows us to access their network without any configuration on their device. So if there's another router, we can still use our door to access their network, and it protects us from them accessing our network. Then also, we have the WebHot router that we want to have a firewall, because if for some reason, because we don't have physical control on the security on the client side. Someone could change configuration, access the router somehow. So we have a firewall as well on the WebHot side. So there's 2 levels of protection there. So here we see that slide. I tried to explain, to show as much as I can the firewall. But one thing first I want to mention, the firewall is not a separate component. It's part of the router. I just wanted to put where the firewall is at the router level. So here we have our firewall on the client side and the firewall on our side, which, by the way, covers also that side of the network. I should have put 2 firewall. So it allows us to protect the user from accessing other client network and our network. And again, we have 2 levels of protection. So if someone take physical control of that router and is able to break the firewall and access here, there's another level of protection on our side. Same thing here. If someone is able to reach that side, he's going to be blocked on that firewall. Well, it doesn't really matter on the client side because as soon as you have access, you have access. But there's still a firewall on top of the authentication. So some service could be limited if we don't want the support team to access those services or block certain machines. So the Netmap that we're using, so the Netmap is a NAT action that creates a static one-on-one mapping of one set of IP address to another. So it allows us to map from provider private IPs to client private subnets. So as for example, we can go from 10.24.00/24 to our client here, the 192.168.0 something, depending on the subnet that we assign to their router, because basically we're going to route traffic to their router with our internal IP all the way until we reach that network. So it allows us to have 2 clients with the same subnet without any problems. This is done on the client-side router, and we have a sample configuration. So basically here, we have a net mapping from the 10.24.0024/24 to 192.168.0/24. And as you see, we just specified the destination address, which is a whole subnet. So you have to understand that this rule will translate the whole network. So the whole one, let's say I'm going in with 240.020, it's going to go to the 192, and same thing for 2540. It's the whole subnet that is being natted to the destination NAT to the proper IP. So we have here, I'm sorry? Which one? No, that's not a typo. That's the network. That's the whole /24. This one you mean? Yeah, yeah, that's. Oh, sorry. Yeah, there's a typo, and you just found something that I didn't do my job properly there. So you have some confidential information here, I guess. Gonna have some work tonight. Yes, that's a typo. I'm sorry, just because there's a lot of 0 in there, so I was a little confused. So yeah, you're totally right. So basically here, we have an example of a user accessing 10.24.020. So his packet is going to go, obviously, through all this. And when it reaches a firewall on that router, it's being changed to 192.168.020. And then he can reach the printer, the web interface, let's say, of the printer. So when the packet goes back, this guy is talking to the IP address on the source NAT that we have. And then the translation is made back to the 10.24.0 source and destination, the technician here. So the traffic is flowing there. So, and then this guy could do the same thing and connect, let's say, on the router board with, well, we'll just assume it's 24.1, 24.1.5, and access the router from his same station without logging into any VPN or, I mean, as soon as if he has access through your rules, he's able to access everything he has to access, which allows you to do a lot at the same time. If you're installing a VM at a client or rebooting, you can connect to that network, start your job, then switch to something else without ever worrying about subnet conflict or any other VPN matter, because those VPN are way more stable than if you have your own VPN with your workstation and all the problems you could have. Yes? Yes, in that situation, we replace the router, but we could use our own router that we just drop in there, and because we're doing a source NAT, it's still going to work, because every communication done on that side is done on the segment 192.168.0. So let's say in that case it's 254. Let's say we drop a router and it's .10. So all communication will seem to come from .10. So everything is going to be returned to the router, then being transferred to the user on the other side. So that's the beauty of it. I mean, either you have your client, which is you manage his whole network, so you put your own router and use it, or you just drop in a small router that someone could just basically go there and drop. A technician could just drop, and it's going to become active with a SSTP tunnel like in matters of minutes, and you're up and running. I'm sorry, I'm not trying. Here? Yeah. No. If it's a SSTP, if it's an IPsec, that's an older old story, which usually when we manage the client, that's what we do. But in cases where we do a network assessment, a new client shows up at our office and they want an assessment, I don't want to send somebody on site the whole day. So we just drop in a router, it connects to our infrastructure, we assign them a network, and that's end of story. We're able to access their whole network in a matter of, I could technically just ship the router. They don't even have to send a tech there. I mean, just plug it in the wall and you're up and running and you have full access. I mean, and that's why it's so simple, and that's why you really have to be careful about security, because then you just open a big door to, if you're not protecting properly and you have someone in your network you don't know, they can do really dirty things. Nasty, should I say. Sorry, my English. Sometimes I don't use the right words. Please excuse me. So that's for the Netmap. And finally, we're using OSPF. OSPF is only on our side. There's no need to install it on a client side. The reason why we want that is to enable us to have dynamic reconfiguration, because as I mentioned in the diagram you've seen before, we have a way more complex network on our side. This is for the matter of that presentation. Today we have a more complex, a lot more routers, I would say 20, 25 routers that manage that whole infrastructure. We don't want to reconfigure everything every time. If there's a subnet for, say, let's say a client comes in and he has a subnet that has no conflict in my network and it's a /16. He has tons of machine. I want to keep it simple, so I'll just add that route in the WebHot router, and the OSPF is configured to redistribute my connected routes. So everything is going to be propagated in my network, and in a matter of 5 minutes, I'm up and running. So that's the reason why we're using OSPF. And also, it gives the ability to have redundancy. Again, on that diagram, I removed the redundancy. But then having OSPF, you can have two WebHop router, and if one goes down, everything is sent to the other one, and the VPN follows, and because the connected routes are redistributed, everything is transferred to your failover. So that gives you a complete solution. So in conclusion, the solution has been a success for our daily operation and gave us the efficiency we were looking for. We've been using this model for more than 5 years. The technology has been proven stable and very economical to maintain. That's something we don't have to worry about. I had way more problems with VPN than this. So after it's in place, it's a piece of cake to maintain. The return on investment is great, and for that, we have to thank Mikrotik for a great product, great flexibility in the product, and that enable us to make that solution a reality without breaking the bank. So that's about it, and I'll let you go for beer. I think a lot of people were waiting for that. I hope I was not too long. Thank you very much. If you have questions, please feel free to come see me or contact me after if you want more details on the solution and configuration, because again, I try to keep it simple, but I'm open to communicate some of the details if it doesn't take hours. So thank you very much, guys.